Welcome back from lunch. My name is Jonathan Fallone. Today you're coming to learn to play with password crackers, which is always fun. Let me tell you a little about myself first. Once again, I'm Jonathan Fallone. I am a senior penetration tester with Knowledge Consulting Group. You can find me on Twitter at ShadyWushu. If you really want to know the origin of that name, you can come talk to me after class. It's a little interesting story. I am a pen tester. I am a gaming nerd, and I'm a general computer nerd, which is kind of where this whole thing starts. In 2010, three things happened. Number one, I graduated from college and started out in the security world. Number two, I built the gaming machine that you see there with the proceeds from my new job. And number three, oclHashcat got released for the first time. So while I was sitting in my new job, reading all my security blogs, I came across this oclHashcat, and I figured, hey, I have this dual GPU gaming machine sitting at home, and right now I'm not playing anything on it. Let me just see what I can do. So I went onto the computer at home, downloaded all the hashes off of it, popped them onto my machine, and I cracked my wife's password in 3 minutes. I told my wife to change her password that evening. That's kind of what got me all started on password cracking. I want to give you a disclaimer first. I do not design or work on any of the software that I say in this presentation, nor do I work for or with any GPU manufacturer. If I tell you that something's great, it's because I actually like using it. I'm not getting paid to say this or anything like that. If you've never had any experience with GPUs, why do you want to use those over just your regular old laptop for password cracking? So CPUs are great inventions. They go and they're good at doing a bunch of instructions sequentially and skipping around to one program to another and splitting their time up. GPUs are great at doing the exact same calculation 1,000 times all at the same time. So hashing is doing the exact same calculation, and in this case we can do it 1,000 times all at the same time. GPUs have thousands of cores. In fact, today, you're not going to find a GPU that's really got under 1,000 cores in it. Most of them are going to have between 1,000 and 3,000 cores per GPU. How many people in here are pen testers, hackers, just like to break stuff? All right. And how many of you are the group of people that are trying to stop the aforementioned group? Great. Both of you need password crackers. For a pen tester, it's kind of obvious. We want to use it for all the hashes that we can't pass. Pass the hash is the greatest thing that has ever been invented since sliced bread. Thank you, Microsoft. But you can't pass every hash. You can't pass hashes from shadow files. If you're using the responder tool from Spider Labs, you cannot pass a net NTLM hash. So you're going to need to crack them. Or, recent feature, maybe in the course of your pen testing, you come across a password-protected document on some CEO's machine. Well, you can use Hashcat now to crack open those password-protected documents. It's a really nice feature. For the security folks in here, you'll want a password cracker to do password auditing. I guarantee you that probably 5% of your users right now are using their username or some variation of it as their password as well. You would probably like to find that out long before I do. You also can use it to generate password statistics for your training programs. It's really easy to go to a group of users and say your password, in order to be secure, has to be so many characters and have all these different characters in it and all that good stuff. It's much different for you to go in there and say, you guys need to start making better passwords because we cracked 80% of all of your passwords in a week. That'll make users perk their ears up. So when I started with KCG, this is kind of like what our password cracker looked like. This is not an exact image. This is off of the good old Googles. But it was pretty similar. It was a Dell motherboard with a old hard drive that who knows where it came from, a processor, an aftermarket power supply, and a AMD video card. It sat on top of a pizza box that sat in the corner of somebody's desk in an office. And that was what we were using for our professional password or our professional penetration test services. When our team got a little bit more established, we figured we needed a bit of an upgrade, and I was fortunate to be able to perform that upgrade. So this presentation is kind of based around my experiences with going out and figuring out how do we build a password cracker and then how do we use the damn thing. So before you begin, you're going to have a bunch of considerations before you can go out and start picking out hardware. Obviously, first, what's your budget? Because that's going to determine everything that comes after that. If you work for a corporate entity, you're not probably going to have unlimited resources. They're going to say keep it under 10 grand, keep it under 8 grand, keep it under 7 grand, whatever. Everything you do after that is going to be based around that budget. You also kind of need to think about how fast do you need to go. For a pen tester, generally, faster is better. Time is money, and the faster you can crack a password, the faster you can get into somebody's machine, the faster you can demonstrate risk. But if you are security personnel, it may be acceptable that you crack 50, 60% of the passwords in 3 weeks as opposed to 2 days. So you might not need to spend quite as much money. Space is going to be a big issue. If you go with a desktop, you're going to be going with a large ATX machine. More likely, you're going to be going with a server, and most of the GPU-based servers are 4U servers. That's a lot of space in a rack. Make sure you have enough space, because you don't want to go and buy this thing and build it and then realize you need to buy an entire new rack and install it just to put this thing in. Always consider maintenance whenever you build any type of machine. You're going to have to put new drivers on this thing, probably pretty often. Security patches, new software versions. Atom does a fantastic job of updating HashCat. There's a new version of HashCat that comes out usually every couple months. So you have to think about the maintenance of putting these new features onto there and who's going to do it. And finally, security. Always consider security. This is a machine that's going to have probably thousands of passwords sitting on it at any one time. You need to think of this thing like a domain controller. It basically holds the exact same information. Don't just go slapping it in somebody's office that doesn't lock at night because you're handing away the keys to the kingdom in that case. Especially if you work for other people, in fact, other clients. If you're a pen tester and you go into another company and grab all of their password hashes, you're suddenly responsible for protecting those just as much as they are. So step one, what are you going to put it in? You kind of have two kinds of different ways you can go. Your desktops are going to be far less expensive. I mean, you can build a really hardcore gaming machine for about, $1,500 bucks. It's easy to get parts. Run down to Micro Center, use your corporate card, you can have it built by the end of the day. But you're not going to hold as many cards. The best ATX motherboard you're going to find out there is going to hold 3 GPUs max. Yes, they may say you have 4 slots, but I guarantee you, if you try to fit 4 cards into your average ATX case, you're just going to start ripping PCI Express slots off of the motherboard. Your servers, on the other hand, are very large, 4U cases normally, but they hold lots more cards, between 4 and 8 usually, depending on what manufacturer you get. They're really expensive. Your bare bones high-performance server chassis are going to cost you probably around 4 grand. That's without anything but the motherboard, the case, and the fans. But you get the added redundancy in them. Oftentimes they'll have 2 processors, multiple fans, multiple power supplies. You get the fact that if something fails, your entire password cracking operation isn't going to go down. Tie-in and Supermicro are going to be probably the 2 most common server cases that you're going to see out there today. They make absolutely fantastic bare bones, high-performance computing servers. Next thing is just fill in all the general bits. You don't need a really great processor. Hopefully, it's not going to be doing too much of anything. It's just going to be running the operating system and making sure everything works. For memory, you don't need that much either. 8 to 16 gigabytes per processor. It's your choice. I'm running 8 gigabytes per processor right now. And hard drives, you just need enough to hold all your word lists. Now, your word list could get very, very big, but I've been running this thing for about a year now, and I've got 1 terabyte worth of space, and I'm using probably about 10% of that. RAID 1 is great to have, because if something breaks on one of them, you've got the other one as a backup. You don't have to reinstall everything. But it's not a necessity. Now for the most fun stuff. Your GPUs. What are you going to look at when you're trying to pick out GPUs? There are tons of these things out on there today. So most of you probably know that supercomputers and everything like that are usually measured in flops, floating point operations per second. Flops mean absolutely bupkis to password cracking because calculating the hash is not a floating point operation. So everything out there that says, oh, my computer goes at this many flops, gigaflops, teraflops, whatever, really doesn't matter. There are 3 things that are important to a password cracker. One is the number of cores we have. This is also a lot of times called a shader unit. This is how many simultaneous calculations we can basically do at a time. Then there's your clock speed. How fast does each core run? How many instructions can we handle every second? And finally, your thermal design power, TDP. A lot of people have a misnomer of what TDP is. They think this is the amount of power that gets eaten up by the GPU. It's actually not true. Thermal design power is how many watts of heat does the card produce under an average load that the computer needs to dissipate. It can be used as a general reference to how much power it draws, but that is, it says it's a 240 watt TDP. That doesn't mean it's going to draw 240 watts. These really don't tell the whole story, though. The problem is cracking speed is based on the number of instructions it takes to calculate a hash, right? You'll see an MD5 will take somewhere between 150 and 350 instructions to calculate. The problem is different cards and different drivers have different instruction sets available, which means that it might take more or less instructions to calculate a hash depending on what instruction sets are available. Different versions of the software, the drivers, might even have different instruction sets. TDP, at the same time, is the amount of power and heat that it creates at average load. And each company decides differently what average load is. So essentially, everything I've shown you here on this slide is completely worthless. None of this tells you what to actually pick, right? So let everybody else do the work for you. There are tons of benchmarks already online. If you go to the HashCat forums, people love showing off their hardware. You can go and see how fast does a NVIDIA 770 run? How fast does an AMD 280 run? Somebody's posted a benchmark, I guarantee, already up there. You can use that to calculate very quickly how many hashes am I, on average, going to be able to crack with certain cards. And then the other thing to do is watch your budget and figure out how to maximize your dollars, basically. Double the price doesn't mean double the cracking power. As you know. It may be that if you get 2 of a lower price card, you'll actually be able to crack more passwords than 1 of the higher price cards. So that's something to consider, especially if you're on a budget. If you'd asked me what my pick was about a month and a half ago, I would have told you 2 things. If you want reliability, you go with the NVIDIA 700 series. NVIDIA makes absolutely fantastic drivers. They are fantastic. They're great. But they're not the fastest cards out there. Their instruction sets were not written with things like password cracking in mind. I mean, obviously, they're writing it for gamers. Why do they want to care about us? On the other hand, AMD wanted their cards to be used for a lot of scientific operations, and they have a lot of instruction sets available. They were much better for password cracking. The only problem with those is that their drivers are absolutely terrible. You can spend half of your time just trying to maintain your password cracker because of a bad driver. So I would have told you, if you wanted to go with reliability, go with your NVIDIA. If you wanted to go for brute speed, go for your AMD. That changed on about September 18th because NVIDIA released their 900 series of cards. These are cards that run as fast as the AMDs that are currently out there. They handle large lists of passwords better. Most of the previous generations of cards ran with a TDP of about 260 watts. These run, the maximum card, the 980, runs with a TDP of 160 watts. It draws about only 2/3 the power and generates 2/3 the heat and runs as fast as any AMD card out there on the market. Plus you get the better parallelism, plus you get the better drivers. This is flat out now my favorite pick for card. If you can go out there and get a 900 series card, do it. They're fantastic. Just wait a month or so because literally everybody is out of stock of these things. There are a few other items you might want to give a little bit of thought to. Cooling and reference design cards. These two go together. You actually don't have to put as much thought into cooling as you think. On a desktop, Yes, desktops don't get cooled quite as well because of all the different crazy ways the airflow has to go. On a server system, though, they usually, for high-performance computing, are just loaded up with giant fans like you see here right at the front of the case. You run these things about 60% of their capacity. It sounds like a Huey taken off, but it will push more than enough air through your server. The other trick is you get reference design cards. Reference design cards means that these are the designs that come straight from either NVIDIA or AMD. The manufacturers are not allowed to change any of the design of these things. The reason that these are great is because both companies generally design their fans to pull air in from the back of the video card. Most of the other manufacturers put giant fans on the outsides of their cards and suck air in through the case. Reference design cards, since they pull in air from the back, means that you can stack them really close together and not have to worry about the airflow going in between each card. There's also no overclocking in reference design cards. Now, normally you'd probably think, but overclocking is great. It makes everything run faster. That's true, but it also makes everything wear out faster. And considering that these cards are probably going to get run at 100% load for days at a time, you're already putting enough wear on them. Don't make it any worse for those cards. And finally, your power. Just go for the overkill. This is the cheapest insurance that you can get for your password cracker. If you get just enough power that you need, it means that your power supplies are going to be drawing 90% load for most of their life. If you spend the extra $75, $100, $200 and get the biggest power supply you can get, it means that maybe your power supply then is running at 40% load for most of its life. Power supplies are the easiest thing to break on your computer. If anybody in here has desktops that they've used hardcore over the past few years, you know probably the first thing to go is your power supply. Good power supply is the cheapest insurance you can have. So I did all this work for you. And the final thing that I needed to do was give it a name. So we had a bunch of discussions inside. What did we want to crack it, or what did we want to call it? Our old one was called McCrackenstein, given that it was something sitting on a pizza box. We put it all together and decided to name it the Kraken. Although we changed the name a little bit, it has a C in it. I know all of you are going to say, that's not how Kraken is spelled. Well, yes, it's a double entendre. See, Kraken. Yeah. This is the Kraken. This is a 4 GPU monster that I have sitting in my server room right now. Like I said, if you walk into the server room, it sounds like there's a Huey taking off. It has the capacity to go up to 8 GPUs. Right now, you'll see there are 4 in there. That's because we blew most of the budget on having a tie-in case that could eventually get to 8 GPUs. We decided that we wanted to have, eventually, all the 8 GPUs, but couldn't afford it at that time, so we just upgrade later. We gave ourselves the ability to upgrade. You'll also notice those are not reference design cards, like I just told you all to get. We simply couldn't get them. That's the sheer reason why there's not there. They didn't have any of them in stock and didn't expect to get them for 4 months. This is only going to be in existence like this for probably another 2 months. I've just got the budget approved, and this picture will change here, hopefully within a month, to 8 NVIDIA 980 cards. So of course you've got to put a whole bunch of software on here. Now I'm going to say something that will probably get me stoned at this moment. I like using Windows. I've always used Windows. I've used Windows since I was 4 years old, and it is great. It really isn't, but what are you going to do? For the love of God, don't use Windows on your password cracker. Use Linux. Use Ubuntu server. It's free. It works a whole lot faster. Now, look, I like Windows. Windows is great. But password cracking on Windows sucks because all the additional overhead means that you're basically cutting your cracking speeds like in third in half. Do yourself a favor. You're building a machine that's entire purpose in life is speed. Go ahead and put a really basic install of Ubuntu server on there. Throw on SSH, because obviously you're going to need a way to access it. You really don't want to go to the console every time you want to do this. Go get your video drivers. Talk about more of that in a minute. And then your password cracking software. I will recommend up, down, left, right, and sideways oclHashcat. It is, in my opinion, the best password cracking software out there right now. And it is free, and it is well maintained. They also have a nice little package of things called Hashcat utils, which are a bunch of utilities that will make your life easier as a password cracker and expand the types of attacks that you are able to do. Highly recommend pulling that one down too. And then finally, all of your word lists, and we'll talk more about word lists in a little while too. When you're setting it all up, install Linux with minimal options. You want the least overhead humanly possible running on this machine. I've installed mine, so I basically only have SSH running on there. I have the basic package completely other than that. No Python or anything like that. You're not using this to develop on. Ensure that the system is secured. As I said before, this is going to be roughly the equivalent of a domain controller. You are going to have password hashes for, if you're a pen tester, all of your clients or your internal company, maybe multiple clients at a time. Make sure your root password is ridiculously long. It'd be really embarrassing if somebody guessed the password to your password cracker. Use public and private keys for SSH if you can. Sometimes, in some corporations, that's really difficult to do because you got people all over the place and some people need access and don't. If you're going to go with password authentication, just make sure all the passwords are ridiculously long. My password for the Kraken is 28 characters long. Do not use open source video drivers. Do not use the video drivers from apt. Download them straight from AMD or NVIDIA. I am a huge supporter of open source, except when it comes to video drivers. You might as well get the ones that are written by the people that are actually putting the chips together. They probably know their chipsets the best. Don't even get them from apt. Apt never has the latest stuff on there. Go straight to the website, as you can see in there, using wget, and just pull down the latest drivers and use those to install. oclHashcat and pretty much every other password cracker out there are going to be designed to work with the drivers that come straight from the company. If you don't use those, the kernels that they use to give you access to the processing ability of the GPUs will not work. This is why I cannot stress enough, only use the drivers that come straight from the company. My wife wanted me to include this slide in there. What am I going to say? So now you've got this great password cracker. You probably spent quite a few grand on it. It's at this big, pretty spot right in the middle of your rack. It's what you show off to clients when you're going out and you're selling your pen testing services. You got, yeah, we got this huge password cracker. Here's a picture of it. It looks great. If you don't know how to use it properly, you've just built an $8,000 paperweight. There are lots of different strategies you can use to attack passwords. Tons. There are entire cons developed to cracking passwords. Passwords 14 happened around the same time as DEF CON, and it was an entire convention of just cracking passwords. I can't even begin to tell you how many different techniques there are. There is no one right way. There are more efficient ways, but anything that you're going to do is going to crack something, essentially, with this much horsepower. But I'm going to teach you my method. The reason I'm going to teach you my method is because it's not difficult. It's easy to learn. It doesn't require a whole lot of time on your part while you're in the middle of a pen test. You can usually throw some commands and a couple of files, your downloaded hashes, onto your password cracker, click go, and let it run and go do something else. You don't have to spend a whole lot of time massaging and writing crazy scripts or anything like that. Using kind of my general framework, since March of this year, we have cracked 67% of all of the hashes we have captured within 48 hours. So when you're doing your password cracking, begin with the fastest attacks. The reason for this is they may not get you the most hashes, but if they get you 2, 3, 4, 5, you can use those then while some of your longer attacks are going on. Even if they're really basic users, if you're a pen tester in here, it's privilege escalation. It's practice. Go in with the least privilege and see how much privilege you can get with those accounts while all of the domain admins are still being cracked. Take advantage of the fact that most users are ignorant to what makes a strong password. If you know that the company has an 8-character minimum, I guarantee you that 50% of the domain is going to be 8 characters long. If the company only requires 2 types of characters, I guarantee you most of the passwords are going to only have 2 kinds of characters. Use that to your advantage to customize your attacks so they're only looking at that stuff first. Yeah, there are users that are going to make better passwords, but go after the dumb ones first. Once you've already cracked a bunch of passwords, use those to help you crack a bunch of others. Oftentimes, companies follow similar patterns. I'll give you one good example. We were pen testing a auto parts supplier. And we cracked, I think, probably about 20% of the domain on our first couple of attacks. And I noticed that a whole bunch of the passwords were the names of cars. So I went out and created a password list of every single make and model of car that I could find that's been built since 1920. I cracked another 60% of the domain. So the organizations often follow certain rules that makes all of the users' passwords similar. If they only require one special character, for example, I guarantee you that that one special character is going to be an exclamation point at the end of a password for most of the users. Once you even resort to doing brute force, which is usually the last thing you want to do, you can configure rules, masks, and statistics to make your brute forcing more efficient, so that you're more likely to get passwords at the beginning of your brute force than you are at the end of your brute force. So step one, as I said, you usually just do brute forcing at the end. But you've got all this horsepower, you might as well take care of the brute force attacks in the really short passwords that will only take a few seconds. This particular command you see right here is hashcat's command to brute force every 6 character and fewer password. The question mark A's are the mask for all characters. There's also a question mark D, question mark L, question mark U, which stands for digit, lowercase, uppercase. So you can actually customize what's being cracked in what position. But in this case, I want to do every single 6 character and fewer password. The M1000 in this case is NTLM. This is a really fast hash. So I know, after benchmarks and everything like that, I can do, on the Kraken as it currently exists, every 6 character NTLM and below in less than 1 minute. I guarantee you that on most of your pen tests, you will find 1 or 2 passwords that still get cracked by this. Shame on those companies. Step 2. Most usernames, many users still include their usernames within their password in some form or another. Yeah, they might convert it to leet speak and add a couple of numbers and an exclamation point on the end, but the username is still there. When you are capturing your passwords, chances are you're going to capture the usernames as well. Use that to build a list, and then throw that list as your dictionary in your password crack. Hashcat also has a great function it calls rules files. Rules files are collections of rules that modify your dictionaries in some method. Some of them have rules that say convert to leet speak, or throw a number at the end, or throw 2 numbers and an exclamation point at the end. They have lots of pre-built rules files that are available for you. Best64 contains the best64 rules. This one here, dead one, is a list of many thousands of rules lists. There's also a great one called generated2 that just came out, which is a list of randomly generated rules that don't appear in any other rule set that they have. If you use a rules file with your crack, you can actually take the username list and automatically do things like convert it to leet speak, add numbers, add characters. And depending on what rule set you use, you may not necessarily make your list that much better. Best64 is generally good for your really slow algorithms, things like bcrypt or SHA-512, whereas dead1, generated2 are fantastic for fast algorithms, MD5s, NTLMs, things of that nature. And in this case, all we're doing is, once again, we give our path to our hash file, but then our path to our list of usernames. This will probably get you another 5 or 10%. Your biggest cracks are going to come when you use your dictionary files. Dictionary files are basically just word lists that you can get and build from anywhere. A word list can be anything. The good old standard these days is ROCU. ROCU is the list of passwords that were captured from the big old ROCU password breach way back. This still is going to net you tons of passwords, especially if you modify those with rules files. But you can use English dictionaries. They all exist out there. use passphrases lists. Where do you get all your word lists, right? There's this great invention. It came out, 15 years ago or something like that, I think. It's called Google. If you Google list of every Wikipedia article out there, you will get a word list of every Wikipedia article that exists. If you Google word list of geonames, you will get a word list of billions of different locations, rivers, mountains, stuff like that. You can find lists of sports teams, cars, books, movies, actors, actresses. There are so many word lists out there. You can also build your own. I told you about how I built a list of cars. I also keep a list of every single password I have ever cracked in the course of the Kraken's life. Now, obviously, I don't keep the hash with this or any reference to any company in there. I also don't put it out for public consumption just because of that fact. But that's the kind of thing you can do. When you crack passwords, save them. Go put them in a list somewhere. Protect that list, but put it someplace. And then finally, use your rules files to extend your word lists to make them even bigger. You're probably going to get most of your cracked passwords from using a dictionary. Another fun little one is the fingerprint attack. Now you're going to get a little more complex. What the fingerprint attack does is it uses the passwords you've already cracked to create every possible combination of characters, up to 7 characters, out of what you've already cracked, which you'll then combine together to make lists of 2 to 14 character long words. The first thing you need to do is just take out all of your cracked passwords. That awk command up there just pulls all of the NTLM plain text passwords that we've cracked and sticks them in an out file. We're then going to use one of the tools that's located in HashCat utils called the expander. The expander is what takes every word that you've already cracked and expands it out to every character in there that you've already cracked. So every possible combination of characters from the passwords you've already cracked, up to 7 characters. Then you go back into HashCat and you use an attack called the combinator. That's that A1 there. The combinator takes just 2 different dictionaries and combines every word in the first dictionary with every word in the second dictionary. So we basically put in our expanded.txt twice. And now we've created a list that is every single character, basically, that we've seen so far on one side, and we combine that once again with every single character we've seen again on the other side. This is a really good way to crack some of those longer passwords, since this basically guarantees that you will have a lot of passwords between 7 and 14 characters. This attack is a really good way, without having to brute force, to grab those longer passwords, those domain admins and everything like that. And from there, it's really up to you where you want to go. It depends on kind of how much you've cracked already, what the environment looks like, what kind of passwords you've seen come out of it. The Markov attack is a statistically based brute force attack. I would go into the math behind what makes up a Markov chain, but I'm really bad at math and I don't really quite understand it myself. But essentially what happens is that in a Markov attack, you statistically calculate, based on the passwords you've already cracked, the likelihood that a character will appear in a particular position in that password, plus the statistical likelihood of what characters will be immediately around it. So what you're basically doing is you're saying, we're going to crack the statistically most likely passwords first, and save the statistically least likely passwords for the end of the brute force attack. You're basically ordering your brute force attack. You can create custom word lists, like I told you with the cars, or you can just do straight up brute force. Sometimes this is best for hashes that are really fast, really easy to crack. NTLM is a great example of this. If you grab a domain, the easiest thing might be just to crack every single 8-character password possible. The Kraken currently can do every single 8-character NTLM password in 8 days. Once I upgrade it, that'll bring it down to about 3. There's nothing that scares a company more than saying that if they like most companies, have that 8-character minimum, there's nothing that scares them more than saying you can crack every single one of those 8-character passwords in 3 days' time, especially considering they probably have a 90-day time to change from one password to the other. I kind of want to show you that this kind of stuff works. This is our statistics that we've had from the Kraken since we started keeping records in March. We actually built the thing in December, but we never really started keeping statistics until we figured that it's probably a good sales tool. So we have so far, since March this year, captured 25,000 NTLM passwords. That number is actually a lot greater. We actually hit one organization where we got 300,000 NTLM passwords just out of one organization. And they'd seen our password cracking statistics before and didn't want us to do it. So far, we've cracked 67.4% of all the NTLM passwords that we've captured. And that number is skewed by a government agency that has a 14-character minimum. They screwed all of my statistics. If we take them out of the equation, it's actually closer to 80%. We have cracked 80% of the NTLM hashes that we've captured within a week. We've captured a bunch of SHAs, net NTLM version 2s. These ones are very good. We capture net NTLM version 2s when we use the responder, and we grab these passwords off the wire. We don't even have to break into a machine to grab them. And since they usually sit, the pen testers, when they come into the company, somewhere near the admins, well, lo and behold, most of the passwords we steal off the wire are usually admin passwords. So we've cracked 43.3% of those, and those are a lot harder to crack than regular NTLMs. We managed to grab 3 blowfish bcrypt hashes off of some Linux device, and we cracked all 3 of them. Doesn't matter how good your encryption is if you're using bad passwords. We've cracked 23% of the MS Cache version 2 hashes that we've captured. These are a lot of times we break into a machine, maybe the company is doing something right and not using the same local admin hash across all of their machines. Well, in that case, we grab the cached hashes. MS caches are actually one of the few things that Microsoft has done really well. MS Cache version 2 is a really difficult algorithm to crack. We still cracked 23% of them, and 23% of those were, the domain admins, so it still didn't work. Finally, your MS Cache version 1, that's just their older version of that. We cracked all 100% of those. All of this here, with the NTLMs we use to demonstrate the domain, how it's a great demonstration using our password cracker to show how the adversaries can get most of your domain in a short period of time. All the other types of hashes on there are how we actually do our job. We go in and we capture these from shadow files, from off the wire, things like that, and then we use the password cracker to crack those hashes within 48 hours and get into other systems and pivot from there. Without having the Kraken in our arsenal, we would not be nearly as successful as penetration tests as we are today. I got to give a couple of thanks out for pushing me to do this one. The first 2 guys I've never met in my life. They have absolutely no idea I'm thanking them for this. Adam is the designer of HashCat. The guy is absolutely brilliant, and HashCat is a ridiculously stable thing for having like a 3-person development team. That's all a side project for everybody. They don't make money off of this. They don't do it for a living. Jeremy Gosney is a member of Team HashCat. He's also a hardware guru. He actually builds these things for a living. When I was building the Kraken, I basically kept posting questions to him on the forum. He'd answer them within 24 hours. He probably hates me now because he's had to answer like 100 questions. Great guy. Chris Duffy, former member of our team, aka Funkin' Wagnall, he pushed me to create this presentation. And finally, Andrew Whitaker, aka the Godfather. He's the leader of KCG's team. He was the one crazy enough to let me actually build the Kraken in the first place. So I kind of had to give him props there. Anybody got any questions? Any at all? Yes? That's actually a good question. Honestly, because in order to get up to the 8-character space, with the amount of storage that we'd have to have good rainbow tables and the amount of time it takes to actually generate those good rainbow tables, You can't find the full 8-character space rainbow tables out there unless you spend a decent amount of money and you have many terabytes worth of storage. In the amount of time it would take us to generate them, we could already crack 5 weeks worth of passwords. I went and looked, and I think I saw, my estimate was that it would take me 3 months to build good, well-formed rainbow tables, whereas in 3 months I cracked 80% of the hashes I had. So I just haven't seen a need for it now. Right, and that's another excellent point, is just it's the amount of processing power it takes to actually scroll through the rainbow tables. You can do that all in parallel. There are technically GPU-based rainbow table, basically searchers, but they're not pretty well optimized. They haven't really been built and expanded on because once GPU computing power reached this level, nobody just really saw a need for them anymore, honestly. Anybody else? There are a few. The current list of basically hashes and everything that it supports is well up in the hundreds. I'm trying to think of some of the more obscure things that it can crack. KeyPass. They just added one if you use the Android encryption. That's now coming standard on a lot of Android phones. Yeah, they got that supported in oclHashcat now. Joomla, all of the like Oracle specific algorithms that they've customized are all supported in there. All of the Cisco specific algorithms are in there. There are only a few that I haven't seen before that are in. And if you think that an algorithm needs to be supported, go write Adam a message. Chances are he'll pop it in there. Yes? That's an absolutely fantastic question. For a normal user, my recommendation personally is 12-character passwords, and try to have at least 2 of every kind of character within the password. 2 uppercase, 2 lowercase, 2 specials, 2 numbers. That really expands the brute force capacity well above even what clusters of these things can calculate in a reasonable amount of time. Once you get up to that level, you're only talking nation-state resources that be able to do it. But that's just for regular users. If you have passwords for your domain admins, for your root level passwords, I default to the good old DoD standard. 16-character passwords, 2 of every type, no dictionary words allowed, and they have to be changed every 60 days. The inhibiting factor to doing this is simply people remembering them. And that's the honest truth. I have a hard time sometimes remembering what password I've used for what site. You obviously don't want to reuse the same password across everything. But if you're using 8 different 16-character passwords across everything, they get really hard to remember. You really need a password keeper. Honestly, more companies need to push 2-factor authentication. That's really going to be the only solution to this. Anybody else? If you got any more questions? Oh, right here. Yep. I mean, Gigabyte, ASUS, EVGA, they all make the reference design cards. Get the reference design cards. Once you get anything beyond that, like I said, they're trying to pull air in through the case, not through the back, so cooling is going to start to become an issue. Those coolers are also generally bigger and wider than the reference design cards, and you start having problems trying to fit them all into the case. And then finally, they're all overclocked. Like I said, you don't need to put any more stress on your card than you're doing. These things will run. I mean, when I do my entire 8-character NTLM space, these cards are running at 100% load for 8 days. I mean, that's something like 100 times what you'd be doing with a normal game. You don't really need to do that. I recommend always get the reference design cards, and most of the guys that build these things for a living will tell you the same thing. Only use the reference design cards. That's 4 cores right there, versus if you have, so even if you have 4 CPUs, let's say those are 16 cores. So what's 16 times 4? Versus if I had 8 980s, that is roughly, that's something like 18,000 cores. Cores are everything. That's how many hashes you can do in parallel. So you'd be looking at doing 64 in parallel versus 18,000 in parallel. You're always going to be faster with GPUs. Yeah, okay, one more I think. Password vaults are fine as long as nobody gets into them. I mean, that's the simplest thing there. They're great normally, but we've found all it does is make our job harder as pen testers, because somebody then leaves their master key or something like that lying around someplace for their password vault. It's the exact same concept of trying to get into the domain controller. You just have to have a different password to get into it. So, yeah, they're great as long as you protect what's protecting the password vault. We found one where a domain admin was keeping all of his domain passwords in a key pass. And after we rooted around his email for 10 minutes, we found the password to his key pass file. So, all right, if you have any questions, ask me afterwards. Thanks, everybody.